If I traded it all, if I gave it all away for one thing, and just for one thing, if I sorted it out, if I knew all about this one thing, wouldn't that be something?
We are looking at blocking in terms of the experimental design. And this is good problem number 2, which is Roman numeral number 7. You are participating in the design of a medical experiment to investigate whether or not calcium supplement in the diet will reduce blood pressure for middle-aged men. You are given a list of 45 middle-aged men. Preliminary research suggests that the supplement may have a greater effect on black men than on white men. So you have 45 men, and race may be an issue between black and white men. Describe a completely randomized experimental design. Completely randomized design starts off with a rat, random allocation of treatments. So let's start off with our rat. And we are checking out a calcium supplement. And nothing else, so we need to compare it to something, to have some kind of control. So let's have a placebo so we can control the placebo effect. And we have 45 men. Half of them will take calcium supplement, half of them will do the placebo. Well, 45 divided by 2 is 22.5, so one of them is going to have one more. That's okay. That can have 23, that can have 22. Measure and compare. And what are we looking for here? Blood pressure? Blood pressure. So we're going to start off with 45 middle-aged men. Randomly assign. $23 to get the calcium supplement. And 22 to the placebo. Measure and compare. Blood pressure. Okay. Number 2. Describe a design that controls the race variable. So there may be some variation here. So to control that variation, we're not going to start off with a rat. We're going to start off with our 45 men. We don't know how many are white or black. So we're just going to block them to black and white. And half of the black men will get the calcium supplement. And half of them will get the placebo. Same thing for the white men. And this is where your random allocation is. It's where your treatments are. You don't randomly assign who's white or black. You randomly decide who gets the calcium or placebo. So just stop and think for a moment. You're not going to put a rat here over by this. That would make no sense. Okay? And then we measure and compare. Blood pressure. So we start off with 45 middle-aged men. Separate into black and white men. For each, randomly assign half to the calcium supplement and the other half to the placebo. And then at the end you measure and compare. Blood pressure. Okay? So that is a block design, and that's what number 3 asks for. What type of design is this? Explain. This is a block. Your reason, separated into similar groups before random allocation of treatments. Which is your rat. Number 4, can we double blind in this experiment? Well, blind means the person receiving the treatment doesn't know what treatment they're getting. Double blind means neither the person receiving nor giving the treatment knows which one is which. So can we double blind here? Yeah, as long as the placebo looks like the calcium supplement. As long as the placebo looks like the calcium supplement, then we can double blind. Neither the person receiving nor giving the treatment will know which is which. A third party with no contact with the subjects will oversee it. Okay? So it's not like we're just blindly giving people. Obviously, we need to know who's getting what treatment, but those people will not have any contact with the subjects in order to reduce possible bias, whether it's intentional or unintentional. Number 5. What does blocking do to an experimental design? Blocking reduces variation. Okay. It has nothing to do with bias. What has to do with bias? That's randomization. If you stop and think about it, randomization reduces. How would blocking reduce bias? How would that reduce the effect, how you feel about who gets what pill or something like that? That's randomization. And that is blocking experimental design. Good luck with that. We're continuing with blocking, but now we're looking at a special type of blocking using matched pairs. Okay? So we're looking at Roman numeral number 8 in our notes. Good problem number 3. You're doing experimental design to see, you want to test whether or not sugar during a test helps the student perform better. You're giving 20 subjects. Describe a design that controls the variation of the abilities of different test takers. Now there's 2 ways you can do match pairs. The first way is matching up similar people. Each person gets 1 treatment. So one person will get a placebo, the other one will get a treatment. Okay, and you randomly decide who gets which one. The second way is each person acts as his or her control. In other words, each person gets 2 treatments. Okay, and sometimes when you have 2 treatments and each person gets it, you sometimes need a washout period. Because you don't want medication acting with each other. So you can't tell the difference if it's one medication acting or another one acting or they're acting with each other. Okay, so not always do we need that, but sometimes you do. So where does that put us? We're looking at number 1. Describe a design that controls the variation of different test takers. So obviously, it might be a little bit difficult to match up people according to ability. You might be able to. Okay, maybe take your top 2 students, match them up, so on and so forth. Start off with 20 volunteers. Randomly assign half 10 to take a test with sugar then wait and give a similar test without sugar. Repeat the process for the other half in reverse order. No sugar first, then sugar. You gotta make sure you do randomly assign though. If that randomly assigned is not in, a lot of people like to forget that on matched pairs. They remember it on the other two because they have a picture, but matched pairs you really don't have a picture. Okay? Measure and compare. Test scores. And that's matched pairs, which is a type of blocking design which can reduce the variation the most. Good luck on matched pairs and all of block design. So we have blocking, which is a special type of experimental design that is used to reduce variation. Sometimes we have different variabilities between gender, male and female, sometimes it's in race, or some other factors may show up. And this is helped to reduce variation. In blocking, we start off with our subjects, block them, then we do a random allocation of treatments, and then we have a special type of blocking which is called matched pairs, and this is used to reduce variation the most. In matched pairs, there are two types where you match people up according to ability or whatever the case may be, and each person gets his or her own treatment. In the other type of matched pairs, each person acts as his or her own control, and that way each person gets two treatments. So that is blocking with matched pairs and also just blocking regular. Good luck on trying to reduce your variation on your experimental designs.